All right, we're back with number 11, so let's try this. We're going to integrate from 0 to 1, x minus e to the x dx. This is section 5.3. We're doing definite integrals. These were all indefinite. They didn't have limits of integration. And I'm looking at this one here. So if I do this one, we integrate. That's x squared over 2 minus e to the x. The antiderivative of that is e to the x. And notice no more integral sign. And I'm going to go from 0 to 1. You just put a straight line here. And you substitute in the 1. And then you subtract substituting in the 0. So if I put 1 in here, you get 1 squared over 2 minus e to the 1 minus, and now I plug 0 in there. 0 squared over 2 minus e to the 0. And that's what 1/2 minus e minus, let's see, that's 0, right? And that's going to be negative, e to the 0 is 1. All right, so that gives me 1/2 minus e plus 1. What is that? 1.5, 1.5 minus e, something like that. Okay. And you can do 1.5 minus e on the calculator, and you get about negative 1.218. All right, fun. Now the last thing we're going to look at, number 12, it's saying find the area of the region that lies beneath the curve y equals sine x on 0 to pi. So we still want to keep the idea of area. So I drew my sine x and I shaded this area, and they're asking for that area. And that area is the integral from 0 to pi of sine x dx. So my integral of sine x is negative cosine x, because the derivative of cosine is negative sine. And we're going to go from 0 to pi. Notice I did the antiderivative. Now I have these limits to put in. I'll put that one in first. And then I'm going to subtract a negative cosine of 0, like that. Now what's that equal to? Cosine of pi is negative 1, and that's plus, right? And cosine of 0 is 1. So 1 plus 1 is 2. That area is exactly 2. That's pretty cool. All right, I'll be back with the applied problem.